Titrations with normal solutions. Normality, which sounds a lot like molality. So yes, once again, another way to express concentration. Normality, with a capital N, a one normal solution contains one equivalent mass of solute per decimeters cubed of solution. When we talk normality, we can kind of think number of equivalents of solute. We can kind of think hydrogens. And this is just a rule of thumb, since we are talking a lot about acids and bases. Because, I say hydrogen because it provides 1 mole of charge. Titration problems can be solved using normality with this equation down here. And it is very simple to do. I did forget to make these guys little subscripts, but normality of acid times the volume of acid equals the normality of base times the volume of base, which is the same equation that's at the top of the next page. If we know 3 of the 4, we can always solve for the 4th. We want to make sure our volumes are in the same unit on the left and the right. So again, it's going to be a different method of solving titrations. The first method we learned was very similar to stoichiometry, and this one is not stoichiometry-like. So we have our acid, in this case, is sulfuric acid, and our base, in this case, is sodium hydroxide. So we're going to use this normality equation. So normality times volume equals normality times volume. We have, then we're going to plug in everything that we know. So we have a 3 normal solution of sodium hydroxide and 20 cubic centimeters of it. Again, my volume units are the same, cubic centimeter. So I'm going to leave them as is. I do not need to worry about changing them to cubic decimeter because it will divide out anyway. What is the normality of the sodium or the sulfuric acid? Sorry. So this is our unknown, and we have 30 cubic centimeters of sulfuric acid. So again, this is going to be boiled down to an algebra problem. So the normality of our acid is 2. And that's all there is to it. I know, we need to do more of these, right? Since this is a titration, we know that the acid and the base is going to be equal in the end. So I'm going to use this equation, number of equivalents of solute per cubic decimeter. So I'm going to use that to start out with. And I have a 4 normal solution of my acid. So that means 4 equivalents and 1 cubic decimeter. In this case, I have 0.2 2 cubic decimeters. And so that is 0.8 equivalents. And if I have that number of equivalents of my acid, I have the same in my base. So I'm going to start with 0.8 equivalents of KOH when potassium hydroxide dissociates. It dissociates in a 1-to-1 ratio, which means there's 1 mole of equivalents and then I can convert from moles to mass, which is 56.1. So, calculator, 0.8 times 56.1, and I get 44.88 grams of my KOH. Sorry, I had to think about that process just a little bit to figure that one out. So this one did not actually use that equation. We kind of reverted back and did stoichiometry to solve that one. All right, the next problem. What is the normality and the molarity of phosphoric acid if 25 cubic centimeters of the solution is necessary to completely react with 30 cubic centimeters of 0.5 normal KOH? So phosphoric acid is H3PO4, that's our acid. Our base is KOH. And we have 25 cubic centimeters, and we are looking for the normality. I'm just going to use X. We have 30 cubic centimeters, and it is 0.5 normal. So this is 15, 25, X. Divided by 25 is 0.6. And this is my answer, my normality answer. But the question asks for normality and molarity. So using this equation got me the normality. To get molarity, I need to remember the charge equivalence. And since we're talking about the acid, phosphoric acid, H3PO4, we have to think number of hydrogens for the number of the charge equivalents. And there's 3 hydrogens. When phosphoric acid would dissociate, it would give up 3 hydrogens, one at a time. But we have to think of that as 3 different charge equivalents. But since we're working backwards, we're actually going to divide. So 0.6, sorry, this one makes sense. There's 3 charge equivalents for that one. But since we're starting with the normality, that's what we know, we're going to divide it by 3. And the molarity of this stuff is 0.2 for molarity, 0.6 for normality, because of those 3 hydrogens on the phosphoric acid. If we had an acid like hydrochloric acid that had only 1 hydrogen, then the normality and the molarity would be the same.